Well, hi, good morning. Thank you so much for joining me in my shop here today. It's June 19th, another hot and muggy day here. So right in front of you, you see two radios. They look identical. These are very, very common radios in this area from back in this era. An area, I mean here in Ontario or Canada. I don't know if these were sold in the States. I don't really know. But these are very common here in Canada. I've had quite a few of these come through my shop. This is called a Baby Champ radio, and in fact one of these was in my home when I was a kid. So I remember mine had this airplane propeller style pointer on it. This has got a single pointer on it. There's a bit of a difference between these two, but there's more than that. Have you spotted another difference between these two radios? How about this one has two knobs? This one has three knobs. And if you look at the scales, a little hard from your distance right now, this is a broadcast receiver, and this is a broadcast receiver with a shortwave band on it. I don't remember the radio I had, or my home had shortwave on it, but it certainly had this kind of propeller. That's how I remember it anyway, but then again, our memories cannot be trusted, can they? Heard that somewhere, but I can't remember where I heard that. So what I hope to do with these two radios is bring them both back to life and do them kind of in tandem, so we can make some comparisons about how they're designed and what the differences are. They could be very, very similar, or they could be quite different inside. I really don't know. Outside, they look pretty identical, except for that extra knob. This one has Baby Champ written right on it here. This one says BC. Well, that's broadcast, and this is shortwave. That's all that is. Ooh. Ooh, wavy. Oh, that's the switch right there. Well, I almost broke that radio right off the start. The switch is very easy to move from band to band. I'll take a peek at the back here. I can't imagine it looking any different. Well, this one's got a lot of stuff on it. This one's got nothing. Oh, wait a minute. It did have stickers. I can see the squares where they were, where these stickers were. It's also missing the screw attachments here. That's a little odd. This back is terribly bent and distorted. Same with this one. I believe these backs are attached to the chassis. And this one for sure has an antenna on it. You can see the wires going to it. This one almost certainly has an antenna on it also, but look at the way it's all twisted and warped there. Pretty warped. Okay, there's some notes on the top. These two radios have come to me through a store in Toronto that I've become friends with the owners, basically, and it's a some might call it a junk store. I've never been in it, frankly. I don't think it's a junk store, but it's a second time around sort of thing. Curios and interesting items, and one of the things they've taken a liking to are these old radios, which they cycle some of them through me, so I can touch them up a little bit, fix them up a little bit, maybe make them work. Not invest too heavily in them, that's the thing. So this one has a note on top that says, "Works kinda buzzy. Clean the pots, clean the pots, clean the pots." And this one says, "No power, no nothing." No power, no nothing. Okay, obviously I think the next step would be to take each one of them out of their cabinets, and we'll take a look at them. Okay, let's get them out of their cabinets here. There's nothing holding it in. Okay, that's one out. Of course, there's the antenna. Well, this one's got one screw holding it together. Is that it? What's the note say? Guarantee notice. This guarantee, which is hidden underneath here where you'll never see it. Tubes are missing in this radio. That's why there are no tubes. It's tubeless. Oh my gosh, no tubes at all. That's not a good start. There's no use, say, putting a couple $100 into a radio like this. It's only worth $50 on a good day. I'm not saying I'm going to put a couple $100 into it. Well, that's a little disappointing in a way. Who took the tubes? What'd they do with them? Oh, it's just full of old stuff. Full of old stuff's got no tubes. This is the shortwave version. This is just the broadcast version. You can see already there's much less parts. In here there's 1, 2, 3, 4, 5 or so wax capacitors. In here there's, I didn't count the molded ones there, 1, 2, 3, 4, 5, 6, 7, 8. They've got them bundled up here, 8 of them. Why would somebody pull all the tubes out of this radio instead of and then still have the radio? That it's gone off and been bought and sold with no tubes in it. Why would somebody not take the tubes out and then throw the radio away? Why would anybody keep a tubeless chassis handy like this? I mean, who would do that? So I'm pretty sure I've got the tubes that would be needed to go into this radio. Okay, so this one's a tube hunt. And this one. So it looks like it has its original filter capacitor, but this could be a replacement. It's quite likely this is actually a replacement here. Where's this yellow wire going? Oh, it's going there. So it's definitely a replacement. And I guess the guy really needed just 2 capacitors to go across the pi filter here, either side of the pi filter, and this is what he had. It's a 40-40 and a 25. It's just floating in here. This section is just held up by various wires. Well, what did the note say? The note said on it, works kinda buzzy, works kinda and is buzzy. Well, that's the buzzy. So I think without starting it up, we'll replace this right away. Maybe you get the schematic and take a look at what size is supposed to be there. Probably 40s, or I don't know what he's got in there. Everything else looks pretty good, actually. Okay. I'm going to replace the, well, no, we're going to get a schematic first. Well, I just want to show you this. I used, again, Bing's or Microsoft's Copilot AI system, and I asked it this question here: what is the model number for the shortwave version of the Baby Champ tube radio? And it came back with the answer. Shortwave version of the Baby Champ tube radio is the Baby Champ 5412. It's similar to the 5400, but with added shortwave capability. Both models feature a built-in antenna and a phono jack with a switch. What? Phono jack with a switch? I don't know about that. If you're looking for a compact collectible radio, the Baby Champ series is a great choice. And it is a great choice because there's a lot of them around and they're not complicated radios. And they have bakelite cabinets, although the one here is painted, unfortunately. Okay, just wanted to show you that once again, stunning to me, the AI system knows a lot of stuff. 5412, eh? Okay. So this is the 5104, the one I have that's not shortwave. And he's saying 5412. So we'll go to Pacific TV here. I looked at this. It doesn't look at all like the radio I have on my bench. I'll show it to you here. It just doesn't look at all like it. This isn't even a Baby Champ. I don't think they call this a Baby Champ anywhere. So, okay, so I'm still on the hunt. Unfortunately, hey, AI, fantastic, but you were wrong, buddy. Let's take a look at Radio Museum. I'm a member of Radio Museum. You can see I've written in under model designation only, just Baby Champ. And that's the only thing I've given it to search on. Off it goes. Many, many Baby Champ radios. 1 to 28 different Baby Champ radio references anyway. But we can switch to the picture gallery here. That's why I'm showing you this. And then you can search by picture. And right away, there it is. 3 knobs. That's it right there. Just a different colored cabinet. This is the white cabinet here. 5002. It's the 5002. So there's quite a few very similar. No wonder there's so many of these radios. They manufactured many versions of it. They all say 46 and 47. 1946 and 47. Oh, this must be the same thing over and over here. There's that other one. So anyway, I found what I needed to find out, and that's the 5002. Okay, let's go here. I'm sorry, let's go here. Whoops, let's even go here. Pacific TV, Northern Electric, 5002. 5002, here it is. Baby Champ mantle radio. Uh-oh, we're just going to get a schematic this time. Oh, here's a picture. There we are, that's it. Okay, so I've now got the 2 schematics that I need. Let's do a little comparison here. Just in case you can hear a roar in the background, that's my house air conditioner running. Doesn't normally run in the morning, but it is these days. So here we are. First, this is the schematic for the broadcast receiver, and this is the schematic for the shortwave receiver. Let's look at the broadcast receiver. So I don't expect to find anything unusual here. You have a loop antenna. Here's the tuning control right here for tuning the antenna. You have another tuning going on against the local oscillator coil. 2 signals are mixed right here in this tube. And what is this little mark here? It's on every tube. Is that supposed to be marking the key? And you can count these, can you? I don't know about that. Not sure about that. So anyway, signal, mixed signal, no front end tube, of course, just straight into the mixer from the antenna. Through an IF, two IF transformers. We come over here to volume control and the take off for the AVC. That's probably the AVC capacitor right there. Okay, so far I've seen nothing unusual at all. The audio is coming out here. Got the capacitor to stop any DC that's in this leg from getting all the way over to here. It's got the plate voltages written right here, 82, 82. It looks like 60. No, looks more like 80. Well, it could be 60, could be 80. 210 here on the output tube. What's that say? Less than 0.5 ohms, I guess, is what that is talking about there. Look at the power supply of a 35Z5. The light bulb is powered from a tap designed to power these lights. And you can see the heaters are all in series, of course. And you've got 35 and 50 and 36. So 35 and 35 is 70 and 50 is 120. So this is adding to 120. You're going to power it with 115. There's going to be a volt missing on a couple of these tubes, but nothing. I'm dwelling on this because of something interesting that's coming. So a 35 and a 50, and then 12, 12, 12. And these tubes are the usual SA, SK. Oh, what's going on here? This is just a K. Where's the S? Let me look in the radio. Well, yeah, just like it shows, there's a grid cap here. Okay, I would have thought this would be an SK7, but it's a K7. But it looks like a modern version. What would have been a modern version of the K7? I don't know. I'm babbling. Power supply, filter is a simple thing. 2 capacitors here. I need to know the size because this is what I'm going to be replacing. C14 and C15. And there's a parts list in here somewhere. Here we are. Just turn it around. C14, C10, 14, and 15 are one capacitor, a 20, 40, 40. And what's in there now is a something 40, 40. Hey, the guy didn't hook up this last wire. What did he do? So the smaller section here is usually used as a bypass capacitor around the cathode resistor on the output tube. So that's why it's only rated for 25 volts also. So 40, 40, 150, I will put in 47s here. 160 rated capacitors. Give them a little extra. And what about this? We got to look into this. What has happened here? So let's look on the schematic again. And we're looking over here at the bypass right here, C10 and R8. Well, what am I going to find out here? It is just as I expected. So this capacitor may be missing in this radio. R8's probably a low, probably like a 150. Let's take a look. R8, 150. I guessed it right on the money. A 150 ohm. Okay, so we're going to look for that, and it's going to be on the cathode of the output tube if I have trouble finding it. And we don't know what this pin number is. Is it really 8? Would this be 8? Am I looking down? Am I looking? I don't know. 8 or 1? Let's look and see. 50L6. What did they do there? Okay, not to get confused between these radios, I think I'm going to set this one. So, how can I get confused? There's no tubes in this one. That's kind of obvious. Which is which? But, you know, I have my ways. So output tube is here. So So if it's pin, so I'm looking for the resistor here that would be on the cathode. There's a big high wattage one sitting there. That's orange, green, orange. That's brown, green, brown. That's what that is. So that's 1.5. That's 150. So there it is. So that's 150 right there. And then in parallel with it, there's a wire leaving under there. Where's it going? There's a brownish wire. Brownish wire. It's going to this. So this is the guy's replacement. It looks like it's a 10 at 30 volts. There's two numbers there, 10 and 30. That's going to be what he did. And then he's got it grounded to the same spot as the original. Original capacitor is cut free. There's nothing connected to the original capacitor. Well, then where? So this is the replacement for the one up on top. That was my guess, kind of. So this guy's got to go, and then we got to get rid of this guy too. I mean, look at this thing. Okay, that's what's going to happen there. Let's take a little peek at the other schematic. I'll show you why. Okay, so this one, the broadcast version, 35Z5 here, and a 50L6 with a 12-12-12 combination. Now we'll look at the other radio. The power supply is also a 35Z5, but look at the output tube. It's a 35L6, not a 50L6, and these are 12-12-12. So look what they've done here. They've put this resistor in, I believe, 2 watt, 82 ohm resistor. Or is that part number 82? I think the small number is the small number is the part number, I believe. Let's find another one here. Yeah, 10M35. So that's what they've done, I guess, is they just put a resistor in series. Why wouldn't they continue with the 50? Why like, what's the advantage here of putting in a 35 L6 with a resistor? They got to pay for the resistor now. Why would he do that? Why would they do that? Now this is the earlier, the later. I don't know. It's the same. I think they're all the same vintage. They all came around 1947 or so. Don't know. I don't know what would prompt this. An excess of 82 ohm resistors in the warehouse, and I got to burn them up somehow. This tube's cheaper to buy. Maybe this tube and this resistor is a cheaper combination than the 50L6. I don't know why they would do that. Let's look for a resistor in the other radio. There shouldn't be one though. I'd be stunned if there is. So we follow the heater circuit here, straight on. So there is no resistor. I don't know why. A cost thing, I would think. Maybe the 35L6 is exactly the same as a 50L6, other than the heater voltage. I think it is. The one to be aware of is the 6L6 is not like the other L6s. The 6L6 is an entirely different super tube. Yeah, you can almost think of the 6L6 like you could think of a integrated circuit called an operational amp, where they try to achieve the best conditions around an amplifier. You know, very high input impedance, very low output impedance, all that stuff, infinite gain and the like. The 6L6 is the tube version of that. Don't quote me on this, please. So it's not really a tube. You can have a tube version, but was an attempt to make a tube that was universally usable. in all kinds of applications. Okay, enough of that. I barely know what I'm talking about again. I'm going to go ahead and do these capacitors. We'll do the 3 capacitors and turn on the radio and see what happens. Good. Okay, here's my 3 replacements here. 2 47s at 160 and a 22 at 25 or 50? 50 volts. Plenty good. Okay, what I'm going to do is I'm going to bundle these by attaching their negatives, twisting their negatives together. I'm going to do these 2 big ones first. You can see I'm just wrapping one of the negative leads around the other. And likewise with this. The shorter wire is the negative lead. And I'm going to solder these together. It'll be like a bundle. There we go. So in a situation like this, where there's one of these capacitors with wires coming out of it, I preserve the wires for use in hookup. I don't think I'm going to need them in this case though. I will preserve them because the one capacitor goes here, the other one goes there. Either side of the resistor you can see in there. And I gotta solder these up. Keep coming apart. And should be easy to kind of position it all in here. I mean, it has to be below the the plane, like this capacitor is sticking out a little bit right here. How come you're sticking out so much? I don't know. Okay, I will install them now. Okay, got the new capacitors in. Take a little bit of a closer look. Got them all kind of jammed together, right in a nice spot there. Excellent. Excellent. Actually, it came out much better than I kind of expected. Great. Okay, let's try turning this radio on now. See what happens. Great. Little coffee break time. Okay, I think we're ready for the test. We'll see if it's working. These are the 2 capacitors I took out. This one actually looks to be in good shape. Yeah, this one does not look to be in good shape. Let me just give this one a little test here. Just for fun. For fun and education. I don't know if I can... Yeah. So this is the low capacitor. It's not the high voltage side of things. Whoops. Okay. Supposed to be 20 microfarads there, I believe. 25 microfarads. It's a big capacitor. It takes time. It doesn't normally take this much time though. There we are, 27 picofarads. 27 picofarads. Okay. Well, there's a red. I paired off a red one too. No, I did. Yeah, let's forget that. Assumption is that's bad. What about this guy here? Get this off. Yep. So this is supposed to be 25 at 50 volts, actually is what it says. 25, so this is supposed to be at 25. Taking a long time again. It's supposed to be 25, so it measures at 35. And that to me usually indicates, from my experience, that the capacitor is leaky, and it throws the test results off in a way that makes it seem like they're better than ever. But they're not. Okay. I think it's time to start it up now. Maybe this is the first, you might be watching, this may be the first video of mine that you are watching. You may be a new viewer. So let me just say something about starting up these radios and why I'm anxious to start it. I find it much better to work on a radio that's working to some degree. And what I mean by that is you touch the antenna and you can hear something come out of the speaker. Having the radio completely dead is risky for doing work on it, because you can't tell if you're doing things right or things are getting better or you're making mistakes, that kind of stuff. So I like to get the radio operating to any degree. And what I've found is that often these radios, like this one right here, I've just done the filter capacitors. That's probably enough. It's probably going to work. That's my guess. Not necessarily, but once the radio is operating to any degree, then you can go through and make more changes, one thing or two things at a time, and test the radio and keep on track as to whether you're making a mistake or not. That's really the idea here. So we're going to turn this down and off. So the first thing we're going to do is power it up with the switch off. That's to make sure the on-off switch does turn it off. So there's power now coming to the radio, and the radio's doing nothing, which is perfect. I'm going to be feeding power to this radio through these light bulbs you see. In fact, just one light bulb. So some of the power is going to be lost in the light bulb coming over here to start with. The reason for this is if there's a really serious short in here, which isn't very likely, but if there is, then all that will happen is the light will come on full blast and the lights will stay on in my house. That's the main thing. Won't set a fire or damage a part in here. Even if the light comes on bright, it's reduced the amount of power coming over here. You have lots of time to take action, turn the power off or whatever. So I like the dim bulbs because they're almost like a warning thing. They come leaping out at you. So the expectation is here. I will turn this on. Let me turn the power off while I'm doing this. I will turn it on. There's no power on now. I'm going to hit the power switch. What we should expect is the light comes on, this light comes on bright, and then dulls down fairly quickly. It maybe goes right out, and then comes up again a little bit as the radio begins to operate. That's kind of the pattern. So bright, down, and then up. That would be normal. Are you ready? I'm ready. Here we go. Bright. It's hard in the camera to tell what's going on. It's slowly going down. This is all of 39, 40 volts coming over here. So we'll just give it a moment while the two heaters heat up. Their resistance is going up, the current draw is going down, and the light is getting duller, as you can see. Voltage is only 62. I don't think the radio can operate with that low a voltage, but you never know. That's a little too low, probably. We don't hear a thing. Okay. So I'm going to jack the voltage up now. I'm going to screw in the second light bulb here. This will provide another parallel path for power to get to the radio. And it's going to jack the voltage up at the radio to pretty close to normal, probably 100 volts anyway. and that might make it work. Let's see. So we got 103, 102, 101. We have a radio operating here. Better stand back just a little bit. Let's tune it. Now this is picking up on this antenna. Here in my shop, getting anything is pretty good. Hey, that's not so good. What's that? The tone is going funny. When I turn it up, the tone... It's almost like I'm turning a tone control here.
Sounds like a bear. Yeah. It sounds like brother.
Some dirt in the control and a restricted tone. I'm pretty sure there's something going on with probably a bad capacitor in there. Now this is probably 590 we're listening to, and you can see it's at 620 or so on the dial. That's probably 640 if I got it right. That means there'll be 680 just up here. There it is. Directionality in the antenna.
Today, and then it will gradually become less humid. 33, though, the guaranteed high today. Rather hazy, chance of showers or storms. It'll feel like 43 with the humidity this afternoon. Mostly cloudy, but a slight chance of showers. 23 degrees. Near 33 overnight. And then the high tomorrow near 30 degrees, feeling like 37. Thunderstorms possible tomorrow afternoon. Some of these storms could be pretty intense. Showers Friday morning, then sun and cloud, and the high near 25. For today, the guaranteed high, 33.
Yeah, so that's coming from Toronto. I'm a little further north, so you can knock a degree off the temperature there. So the high here is probably going to be 32. But the humidity is very, very high today. It's very uncomfortable outside already. But I can't complain, because there are people in this world who are literally in circumstances they can't even live their lives right now. And it's certainly not the case here at all. So it's just a hot summer day, that's all. Just come a little early in the year, in the summer. So, you know, the radio's operating. It could be sold off like this now. But there's a couple more things we should really check before letting it go, including the alignment and some biases, and maybe we should go after all those bad capacitors that are in there. If this one didn't have all that many, if I remember right, it was just a few, like 3 or 4. So we have this big guy here. Those ones, we got a molded one here, and coming off the volume control is this guy, a mica one, so I'm not going to worry about that one. Is that coming off the volume control? No, it is not. This is the one coming off the volume control. Looks replaced to me. Probably was a wax capacitor and it got replaced with this fantastic molded capacitor, which is not really so fantastic. Just thinking about what time it is this morning now. Well, I got going pretty early this morning, so I still have some time left. I didn't notice any particular performance issue with the radio, other than the alignment's a little off, the dial was a little off. Its performance is okay though. Should I just leave it like this? Well, you're all yelling, no, no, no. Change those capacitors out. Let me go after the ugly one here. This is probably, it's one side is grounded and the other side is hooked up. That's probably, let's look for this one on the schematic. It's hooked up to a, looks like 22K resistor right here on a tube. Let's look for it. Oh, I don't have the values written here. Shoot. So the tube it's on is the is this one here, and you know what? I'm not going to be able to identify it. It could easily be, oh, could be this one. What's R3? Wow, should be a lot more than just 20, 22. I've lost track of what I was looking at. There's a whole bunch of resistors in here that are 22s. There it is. Yeah, that's an orange. So that's 22K. 22K. We'll look in the list of R's for 22K. 20. There's one. That's R2. That'd be the only one. That's the only one. So there's only one 22K resistor. Where'd it go? Here it is. 22K R2. So we'll look back on the schematic and we find out that this is R3. There's R2 right there. So R2 is connected to here. So this is almost certainly the capacitor we're dealing with here. C12. What's the size of C12? Whoops, wrong way. C12. 0.05. Nothing spectacular about it. 0.05. There's a big one there, 0.2. That's what I thought we were going to end up with. This big guy. Okay, let's go back. We'll cut it out and see what it is. See what's in there. Again, if you're new to my channel and wonder what am I doing with a clip lead right now, I clip onto the terminals so I don't forget which terminal the part came from, because I have a nasty habit losing track of that. This side is just grounded, so it could ground anywhere. Like there's a real nice spot right down here. You know, the components have a size and a dimension, and the designer of the radio has to take that into account. So we can't plan to have, it's not good to have a capacitor like this connected to two terminals really close together. So you're more likely to try to arrange the radio so there's space between terminals for the big components to go in. This is really dirty. How come so dirty? Okay, well, I gotta look at this with the other camera. Point 2. I thought it looked awfully large. Thought I managed to get all that wrong. 0.2. 0.2. Let's look at the schematic again. Okay, look for a 0.2 capacitor. I mean, there can't be many of those in here. There we are, 0.2. And it's C13. There's no other 0.2 in here, right? No. So it's got to be C13. Oh, look at this. Ha, I forgot about these, yes. So where I am is right up in here. It's this one. Yeah, C13. I just misidentified it. Well, this is a great thing, these photographs. I whipped by them and they didn't really register that they existed. That's great. So C13, 0.2. Well, 0.2 is not so great. I gotta find a 0.2. And is it sustaining big voltage? It probably is. 0.2. Maybe not. So we follow this all the way over to here. We're going to end up. Oh, wow, is it ever hard to see? But this is the diode here. And this connection, I believe, is the other diode. The two diodes shorted together. So this is the output. Very little voltage here. Very little voltage. It's very little voltage here. I mean, this is a grid bias control, automatic volume control, automatic grid bias volume control, I guess. Put all the words together. And the voltage here isn't going to go much beyond 10 volts, minus 10 volts. You need nothing in here for, you don't need a powerful capacitor here. But what we need is a big one. So I need a big 0.2 low voltage capacitor. I think I can find that. Ooh, I almost forgot. We should test this capacitor. On my capacitor checker here, this is designed, this is back in the day when tubes were around, so this is designed for testing capacitors normally found in tube radios. And the issue in a tube radio is voltage, high voltage. So this thing will produce some high voltages, put it on the capacitor. If current leaks through the capacitor, this eye will close. If there's no current leaking, the eye stays open, just like you see it now. Initially, when I hit the switch here, there'll be a rush of current into the capacitor. The eye will snap closed and then it will drift open again. Let's see. So I said it would drift open again, but it's not opening. So what this means is there's a serious leak in this capacitor. Now, just to keep me honest, I'm going to grab any new capacitor here. Yeah, just come on, any new capacitor. Here's one. Oh my gosh. Give it 2 seconds to grab a capacitor. It took me that long. So here's just a regular capacitor. This is a 600 volt capacitor, 0.01 or 0.001 small guy. Okay. What I'm going to do is I'm going to test this right up to the limit of 450 volts. And you'll watch the eye. This is me checking the test to make sure the test is valid. Here we go. Okay, 50 volts, right open. 150 volts, right open. 250 volts, right open. 350 volts, right open. 450 volts, right open. So that's what a new capacitor does. These old guys that I'm testing, they don't stand up to this test at all. By the way, I've charged this capacitor up to 450 volts. It's a new capacitor, so it's going to hold that charge. But not with this device. When you let go of this control, it puts a short across the item you're testing, the capacitor you're testing. Drains it out. So she's safe. I can put it back in my drawer. Yeah, a brand new capacitor like this would hold a charge for a long time. Long enough for you to get a lift off it. And I'm not looking for that experience here. Okay, very good. Capacitor shot. The reason for testing them is each capacitor I take out is kind of an example of what the rest of them are like. So you take a capacitor out, test it bad, all the rest are probably bad. They've all been traveling together here in the same ship. Let me put this back in my drawer. Okay, conveniently closed, so I'm not sure which drawer I grabbed it from. So yeah, that's right. Low voltage 0.2. Gotta find a 0.2. Okay. One of the things I've neglected to do to this point is take a look at how the power cord is handled in a 5-tube radio like this. There's always an issue about how is the chassis connected to the radio circuitry. In this radio, I see a little bit of some confusing sort of things to me. So here is the capacitor I'm actually working on. It's not what I thought it was at all. It's over here, and it's tied to the B minus line, and it's going to the chassis. Now in some radios this would be it. There would be just this capacitor going to the chassis, and that's the only connection between the chassis and the radio itself. And that's a good thing, because you see the plug is unpolarized. You can put it in either way in the outlet. So one way this would be at earth potential, and the other way would have 115 volts on it. So if this were connected directly to the chassis, you'd be inches away from getting a shock off this radio. All you had to do is just touch the chassis or something related to the chassis. So in many radios what they do, they don't connect the chassis into the radio circuitry. Well, they have to. Otherwise you have a large piece of metal floating all around all these parts, and that metal will convey signals around and cause problems. So what you want to do is hook the metal up to this B minus. Hook the chassis to the B minus, but do it in a way that protects somebody should this be plugged in a certain way and this be live and the chassis be live. So what you do is you isolate the chassis with a capacitor. That way, if you get a shock off the chassis, the current flow is limited by the capacitor. This is a 0.2. It's not limiting very much. Now usually they don't just have a capacitor, they also have a resistor, and they would show it on the schematic right here. It would be a resistor shown right here. But in this schematic there's a resistor shown over here. A resistor to the chassis. Now if this is the kind of resistor I think it is, it's probably about 150,000 ohms. So let's check. It's R12. It's R12. R12. 220,000 ohms. Okay, well that's close to 150,000. It's a fairly large resistor there. That's typical. That is typical of what I'm talking about. And what am I talking about? Get back to the schematic. Talking about how the chassis is handled. So I was about to put a low voltage capacitor here because I had in my head I was dealing with this one, but it's not. It's this one. The capacitor here has to be able to sustain the line voltage. Not sure it has to sustain much more than that. But this is a safety issue, so it's better to put a safety type capacitor in here. C13, is it really a 0.2? C13, 0.2. Wow, it's really big compared to what I would imagine. Part of what's going on here, and what I'm going to say may not be completely true, I may have a partial truth here, is the antenna can work better. Yeah, I'm not going to finish that. I was going to say at the end. Yeah, I'm not going to finish that. I was going to say. It's a loop antenna here. So part of the reason for the loop antenna is to remove the need for a ground connection to make your antenna work well. So what I was going to say was part of what this is doing is making the antenna work well. No, but if you were to put a wire antenna out here, that's what this is for. So you stick a piece of wire in your backyard. That might work better because of this capacitor connecting to the chassis, which is ultimately connected to the electric system, which just is providing more and more, I got air quotes going here, grounding for the antenna to work against. A wire antenna to work against. A loop antenna doesn't need that. So again, I could be totally wrong in this, but I think that's part of the picture here, and maybe that's why it's so large. But really, this radio is not intended to have a wire antenna. It's intended to operate with a loop and to be listening to strong local stations. That's really what the intention was. You're not trying to fish radio stations out of the ether from far away with a radio like this. So what voltage do I need to put in here? Now what's in here is a 200, but that's probably because that's what they stocked. They stocked a few sizes and voltages of capacitors to keep their stock catalog low in the factory. So it doesn't necessarily have to be 200. Or does it? So if you plug this in backwards, you have 120 volts here, but really you've got 169 volts peak on here. So the capacitor has to take 169 volts. Sounds like 200 is the right rating for here. I gotta find, oh, this is a problem for me now, 200 volt, 0.2. Okay, I gotta hunt it down. Well, I'm scrounging around for capacitors here. So here's one. It's a filthy thing. 0.2, 400 volts. Probably good. I haven't tested it, but I mean, it's NOS, new old stock. But look at how big this thing is. It's because it's a 400 volter. Could I fit it in there? Could probably fit it in there. Another alternative then is this one. It's a 0.22 at 400 volts also. It's much smaller. Let's test this one. It's an ugly looking capacitor, that's for sure. So you're probably, how did you get that, Jim? Where'd you get that from? So I have gotten the remnant stock of 2 stereo shops. The scraps, the final scraps, given to me, and that's where some of this came from. So it was rolling around in somebody's box of stuff, and I got all dirtied up here. So here we are, 2.7 nanofarads, 270 nanofarads. Ooh, this isn't going so good. I don't want it to read a little high like that. It may be as bad as it looks. Let's try this one. $230. That claims to be $220. So I think this is the winner. And I'm going to have to order more capacitors because I am really low on these big capacitors. Are a little expensive, so you're going to stock a bunch of them. It's going to hurt. So it could go in like that, like the other one was. Can't go between here. That's too short. So yeah, so I think I'm going to put it right back in the same spot. Nice little spot reserved there for it. Right in like that. This ground terminal, I left a little bit of wire. ready to solder. Not much left. Okay, looks good. Now, so what I think I'm doing, but I'm not sure, is I improve the safety of this radio by removing a leaky capacitor that's tied between the B minus and the chassis. And I put in a capacitor that has no leak, so you are much less likely to get a powerful shock off of this radio. Another approach is to switch the plug with a polarized one. I tend to stay away from that myself. You can even do a 3-prong plug, but I stay far away from that approach. Okay. Should we operate this radio? Make sure it still works. Or do another capacitor. Let's do another capacitor. So we have a 0.05 sitting here. I got an uglier one down here, a molded one. Maybe a better approach. Look at the schematic and identify what capacitor might be an issue. Let's try that. Of course, any capacitor can be an issue. One I would be looking for, I would follow the screen here and look for. How about following the screen here? Well, this is really not easy to do. Again, it didn't work out very well. Here's a screen. Let's follow this one. Okay, we're going from here, 82 volts. No, it's just all by itself. Oh no, here we come out of here. That's a plate supply. This is just the general B plus line. That's a plate supply. Here's a screen here. So we have a plate and screen supply. Now, is there a capacitor on this line somewhere other than that one? No, there is not. I'm surprised. Just these big guys here, which I've changed out. We got this guy, C22. He's right across the power line. Oh, C22. Yeah, we better see about 22 here. C22. Oh, 22, not 2. 22. Capacitor, paper, 0.025, 600 volts. So we got to replace that one. We got to find that one and replace it. That's right across the power line. If that shorts, why, you could stop the water in Niagara Falls. We can't have that happen. 0.025. I gotta find it. Oh, there's got a diagram here, for crying out loud. C22. We can see 22. There. 22 is this one. Okay. Now I'm just looking in the radio myself. The radio is flipped around. flipped around. So this guy got 1, 2, 3 out of the corner. 1, 2. It's going between 2 tubes here. I think I see which one it is. I'm gonna have to do it by tube. Here, let me set something up. Okay, let's try this. We can compare. So I've turned the radio over. It's the same orientation as the diagram. You can see the volume control here and the volume control there. You can see this capacitor matches up, and we see one here. I don't know if that's molded in the diagram, but that's the same one I'm pointing to. You can see it's the same angle. What I'm really interested in is actually partially off the screen here. And I've literally forgotten what the heck I'm doing this for. Let me fix this here if I can a little bit. There. Okay. Trying to identify a particular capacitor. Can you remember? Can anybody remember? Who can remember which one it was? I was trying to. C22, I believe. C22. So C22 is on an angle like this. Well, there's no capacitor on that angle. There's this one sitting here. It's got a lead to here and a lead up to here. So it could be like this. And that would be it, wouldn't it? But it isn't. They've run a wire around like that. So this is it. Oh, what's this? Where, oh no, what is this? So this is a problem. Where did that come from? Did I just... Oh, it looks like a cut. It's almost certainly going down to the negative terminal, down under these capacitors. What the heck is that there for? I don't think... I think the last guy cut it and just left it. And then he installed his capacitors. His capacitor. This guy? Or is this? That's this. This is this. Come on, Jim. Just try to get rid of as much of it as I can here. We're plugged in? No. Okay. One of the giveaways that it's not hookup wire is it's stranded wire. So this has come with stranded wire. But the rest of the wires would be just single conductor hookup wire, I'm pretty sure. Okay. What am I doing now? So I think this is the guy, 0.025. And that's, I gotta look at this schematic here, or you can just look at it like this. Part of it anyway. So, oh my God, I'm just, you know what, I've been in here too long already. C22, 0.025, that's what that capacitor is. That's all, that's what I really wanted to look at. 0.025 in there. Okay. We will deal with that. 0.025, where is it? Oh man, oh yeah, across the power line. Yes, 0.05. Oh, I got a beauty for that. Good. Okay, let's give this guy a try. This is an Aero capacitor. I'm not sure I've heard of that company before. It looks to be in really good shape. There's a bit of a gap where the wire's coming through, but that's from me bending the wires and that. Let's see. Is the Aero company making good capacitors? Okay, so 50 volts. Here we go. Wow. That's suspicious. When it pops really fast, suspicion is there's no capacity in the capacitor, because this is just pop. I'm at 350 here. This is crazy. Oh, did we see that? So I think it was open, and I just shorted it like. Let's give it a moment here. So I think what happened there was either these leads were not making contact, or inside the capacitor there was no contact. When I got up to a high enough voltage, a little spark jumped the gap, weld the parts back together, and now you can see clearly it's a piece of crap capacitor. Yeah, cannot tell a capacitor by its cover. Okay, so good thing that one's being changed. Clearly they're all shot. I mean, how often have I found a radio with good wax capacitors? And it has happened, but it very, very seldom. So here's my replacement. It's going to go across the power line here. Where? From here to here. Now I've left this green wire lead so I can use it. Perfect. What happened there? Did I cut the wire right off? Oh, pull the insulation right off. There we go. I call this the hooky thing. You just bend a couple hooks. You know, I went to school all the way from grade kindergarten all the way to grade 13. We had a grade 13 here in Ontario at that time, and I never skipped a single class ever. Never even dawned on me to do such a thing. I guess I'm going to leave this bare wire just out here. Of course, part of that was my dad was a high school teacher, so when I was in high school, it wouldn't be too hard for Dad to find out son's not at school, particularly because I was in his homeroom. Can you believe that? My homeroom teacher was my dad, and for 2 years he was 2 years my homeroom teacher and 1 year my math teacher. It might freak you out thinking, oh my gosh, you're going to go and sit in the classroom and your dad's teaching you up in the front and all those kids are challenging him and that. Well, my dad was older and he was quite experienced. This is off. So he knew all the tricks in teaching. It was all second nature to him by the time I got into his class. He'd been teaching for 20 years or something 15 years or something like that. The rumor around the high school was the jokes my dad told during class he had written in his day book, because people who failed his class and repeated it heard the same jokes on the same day in the same lesson. I don't know if he did that. He never left any of his school information laying around. Like when he was my teacher, I couldn't look, and I wasn't interested in the other students' marks and stuff like that, but I guess I could have looked. Yeah. He was not excited about being a teacher. Okay. So I've put this in. By the was talking while I did it, so I better check. I have this connection out here in space, but I think that's okay. I think I'm going to test the radio and call it a day here. Okay, I'm going to switch it on. There's no power yet. Okay, we're going to go through the 2 dim bulbs. Here we go. Now when I have something, again, if you're a new viewer, if I have something plugged in on my bench, I'm plugging it into this guy. This guy goes to a isolation transformer. So it's isolated from the power line neutral or ground, or there's no reference between the power here and earth and ground. Makes me a little safer. You're going to sound about the same. So I'm going to do a little trick here. I'm going to try to boost the signal in my shop. I have a good outdoor antenna. It's actually an active antenna. Has a amplifier in it. So it picks up the signal outdoors and amplifies it, sends it down the cable into here. And what I'm doing is, so I'm hooking this coil up to my outdoor antenna. And then I'm going to bring it up. That's a little better. It's receiving fairly well.
Get a $500.
From these deliberations, I think.
And I had the potty trained him as he pooped on the living room carpet. I stuck his nose there. 3 times later.
This is 820, and you can see where it is on the dial. And if we take away the booster, the poor radio can't hear it. Some distortion in that.
And you put it in your mouth, you put the stick in your mouth sideways. I am not kidding. This little idiot dog found a stick about as long as she was. She stuck it in her mouth to run with it, but it was sticking straight out the front. This dog through her, all sitting on the couch watching TV. She comes running through the house as fast as she can. That stick's sticking straight out. And as she runs across the carpet in front of us, for some reason she decided to quickly look down.
Oh, jeez. It's a terrible story. I don't want to hear it.
Okay. But that wasn't, at the time, Jerry, they released him and said that
Certainly sounds a little distorted to me. It could be the speaker. Okay, that's it so far. Very good on this guy. Yeah, so today I will hunt down tubes for the other radio, and we'll try that one out tomorrow. I'm not finished with this. I've just got it to the point where it's working quite well, and I can move on to the other radio and get it working. Anyways, thanks a lot for watching, and we'll see you tomorrow.